I'm Dr. Chris Nelson, Principal Consultant at Noise and Vibration, and currently I spend most of my time doing expert witness work for personal injury claims on noise-induced hearing loss and hand-arm vibration syndrome. Hand-arm vibration, HAV, is the sort of vibration to which people's hands or fingers are exposed at work, for example when using a power tool or putting their hands in contact with any other vibrating machine. It shouldn't be confused with hand-arm vibration syndrome, HAVS or HAVS, which is a collection of medical conditions that can arise over time as a result of that exposure to vibration. And HAVS includes vascular problems where the blood supply to the fingers is interrupted, sometimes known as vibration white finger, and also neurological symptoms, numbness and tingling, loss of dexterity, and vibration exposure has also been associated with carpal tunnel syndrome, another neurological condition of the hands.
I'm Stuart McGregor. I work as a noise and vibration consultant. The health impacts of hand-arm vibration syndrome are well documented. The primary symptoms, the white finger, the pain, etc. that's associated with that, people are broadly aware of. Perhaps as significant an impact is the secondary effects, and these are things that are affected by the lack of dexterity that comes from the health issues. Things like doing up buttons, doing up your shirt button, your trouser button, perhaps unzipping a bag, operating a smartphone where you can have the loss of dexterity and the temperature, and of course there's also your shoelaces. These are all things we completely take for granted, and could you imagine trying to get out in the morning without being able to do any of these things?
Hand-arm vibration exposure can occur across a wide range of industries, and those that we typically come across include the construction industry, utilities, roadwork for example, horticulture, grounds maintenance where people are using strimmers, hedge cutters, lawn mowers, and manufacturing industry, particularly the heavier end of manufacturing industry such as steel fabrication. The highest risk vibrating tool within an industry depends very much on the work that's being done with the tools. Some tools have a very high vibration magnitude or vibration level, but are used for very short periods of time. Other tools might have a lower vibration magnitude but be used for most of the working day, and they would therefore carry probably a higher risk.
We're all familiar with the traditional industries, the mining, the foundry worker, the shipbuilding, etc. But what we're seeing increasingly is really people exposed in industries that perhaps aren't obvious. These would include things like motor vehicle repair, and it's really that type of model, the lower vibrating tool that's been used for a long time, that's where really the risk is now becoming more evident. Other examples could be things like dentistry, where dental technicians are making fillings, teeth, etc., crowns, that type of thing, and also specialist flooring contractors where they use specialist tools to remove the industrial flooring material prior to new product going down.
Hand-arm vibration syndrome is preventable, or certainly in its severe cases, and really it isn't about numbers, it isn't about lots of difficult, complicated calculations. It's about recognising where there's a risk and getting on with changing the work process so that that risk is controlled.
If I was to turn up on site looking at hand-arm vibration, whether it was in my previous role as an HSE specialist inspector or in my current role where I might be looking at a compliance audit or a verification due diligence type audit, what I'd really be looking for is the company managing the risk, is it protecting people, and has it got the risks as low as reasonably practicable? It really is that simple. The first thing you'd look at is have they applied a hierarchy of risk control. So the first step in that is, have you eliminated processes or tasks that aren't necessary? The next step is, when you've established that that task needs to be done, have you reduced the risk as low as reasonably practicable? That may mean, are you using a lower vibrating tool? Are you using the most efficient consumable? Are you using the most efficient process? The next step down is how are you then managing the residual risks that are left? And by the residual risks, what we mean is the risks that you cannot easily eliminate. Now, these might be managed by worker rotation, so it may be a management technique that does it, so the risk is split between 2, 3 or 4 people rather than one. It may be done by splitting the task over several days rather than one, or it may be finally captured, any risk that remains, through processes like health surveillance. Finally, there's also information, instruction and training, which is absolutely pivotal to ensure that people can manage the risks. So it's really about selecting the right tool, the right process and the right consumables. And when you combine that with all the other aspects, you've reduced the risks as low as reasonably practicable.